Welcome to Laboratory Experiment in General Chemistry. Today we continue Unit 3, Density and Chemical Equivalent. About density. Density is an important parameter of a substance. It can be used to identify that substance because density is an intensive property. Intensive properties are properties that do not depend on the quantity of the substance. The density of a substance is the ratio of its mass per unit volume. For solid, two types of density are used. True density is the mass per unit of true volume, exclusive of all void and pore. And the Planck density is the mass per unit of total volume, inclusive of void and pore. So therefore, determine the density of solid is more difficult than determine the density of a liquid. In this laboratory, we also determine the equivalent weight of a metal. Equivalent weight is a weight of an element or compound which will compile or display 1 part by weight of hydrogen or 8 parts by weight of oxygen. And we have the law of equivalent proportion. In a reaction, the substance reacts with others in quantities proportional to their equivalent weight. And we have the definition of number of equivalents. Is the mass of substance divided by equivalent weight. So therefore, in a reaction, the number of equivalent of all substances are equal, and we have the expression Ma over Ea equal Mb over Eb. This is the number of equivalent. The mass over the equivalent weight is the number of equivalent. How to determine the equivalent weight of a metal? If the metal can react with hydrogen, we can use the hydrogen displacement method. We will react with an acid, for example, hydrochloric acid, to produce hydrogen. We already know the equivalent weight of hydrogen is 1. So from the law of equivalent proportion, Ma over Ei equal the mass of hydrogen over the equivalent weight of hydrogen, we can obtain the equivalent weight of aluminum by measuring the mass of the hydrogen released. In order to measure the mass of the hydrogen released from the reaction, we can collecting the gas and measure its volume. From the volume, the pressure and the temperature, we can obtain the mole of hydrogen by ideal gas, and therefore the mass of hydrogen can be obtained from the mole of hydrogen. The mass of aluminum we already know by weighing, so therefore the equivalent weight of aluminum can be obtained from this relation. Again, right? Summarize, we can, the measure of aluminum is determined from weighing. The mass of hydrogen determined from the volume of the gas released and the pressure and temperature. The equivalent weight of hydrogen already known is 1. So we can obtain the equivalent weight of aluminum. The density measurement. We will measure the density of water, liquid, and the true and Planck density of sand. When measuring the true density, we use the density bottle. Density bottle is the bottle that has an exact volume. For example, in this case, 50 milliliter density bottle. The exact volume of this bottle is 50 milliliter. So we have exactly volume, measure its mass, we can determine the density of water. For the true density of sand, we use the water displacement method. We put the water and sand inside, so the volume of the sand will equal the volume of the water displacement. So we can obtain the true volume of sand, and then we can obtain the true density of sand. For the bulk density of sand, we can use the rat-rated cylinder to measure the total volume of sand and measure its mass, can determine the bulk density of sand. Okay, now is the setup for determine the equivalent weight. I can explain this setup briefly. Right. This tube is used for the reaction between the aluminum and hydrochloric acids. The gas evolved will go to the tube and push the water out by measuring the volume of the water displacement. We can measure the volume of the gas, hydrogen gas produced, right? And also we measure the temperature and pressure by equalize the pressure inside with the pressure, the atmospheric pressure. We can determine the mole of hydrogen gas. Okay, see you in the lab. Thank you for watching.